The next topic we are going to see is X.25. So X.25 is a protocol that connects DTE and DCE. DTE is data terminating equipment and DCE is data circuit terminating equipment. So what is DTE? DTE is data terminating equipment and DCE is data circuit terminating equipment. This X.25 is a 3-layer protocol. So how many layers X.2 is having? It is having a 3-layer protocol. Now, what is data terminating equipment? The terminals, personal computers, and network host. These are called data terminating equipments. So these equipments are located on premises of subscriber. Then data circuit terminating equipment. Modems and packet switches. These are called data circuit terminating equipments. Usually, these devices are located at carrier facility. Next one is package switching exchange. Okay. The switches that make up the carrier network are called packet switching exchange. Now, this X.25 is a 3-layer protocol. What are the 3 layers? Physical layer, data link layer, and network layer. These are the 3 layers. So X.25 is a protocol that connects DTE, that is data terminating equipment, to data circuit terminating equipment. This X.25 is having a low data rate of 64 kilobits per second. What is the data rate of X.25? 64 kilobits per second. This X.25 is a virtual circuit switching network. What type of network is X.25? X.25 is a virtual circuit switching network. This X.25 was originally designed for private use. This X.25 has its own network layer. Okay, it will be having its own network layer. So if the user want to send the data, then the data will be encapsulated in that network layer. So X.25 is a standard approved by I2U. Now, this X.25 is designed to provide a low-cost alternative for data communication over public networks. So the thing is, we have to pay only for the bandwidth what we are using. So it is a low-cost one. So this X.25 support bursty data. So what does it mean by bursty data? Bursty data means the data which is having different transmission rates. This X.25 provides error control and flow control at 2 layers, that is at data link layer and network layer. This X.25 will provide error control as well as flow control. So you can transfer the data reliably. So this X.25 can support speed of 9.6 kilobits to 2 megabits per second. So it can provide multiplexing of up to 4095 virtual circuits over DTE DCE links. How many virtual circuits it can provide? It can provide 4095 virtual circuits by multiplexing. Now we are going for X.25, comparing X.25 and OSI. So in OSI you are having 7 layers and in X.25 you are having only 3 layers. The 3 layers are physical layer, data link layer, and network layer. So in the physical layer of X.25, the protocols or the devices which is defined as EIA 232. This EIA 232 is similar to this RS 232. So this is nothing but a connector. Next to V series connector and X series connector. So here in the physical layer, some connectors are defined. These connectors will be having varying pin numbers and varying data rate. And in the data link layer, link access procedure balanced protocol is used. In data link layer of X.25, which protocol is used? Link access procedure balance. This link access procedure balance protocol is a version of high level data link control protocol, HDLC protocol. It is a version of HDLC protocol. And in the network layer of X.25, packet layer protocol is defined. What protocol is defined in network layer? Packet layer protocol is defined. Now, first we are going for the X.25 physical layer. Several well-known standards are used for X.25 networks. So, first one is X.25 or X.25 BIS. It will support the data rate up to 2 megabits per second, and this X.25 is a 15-pin connector. Next one is RS-232 or EIA 232 or TIA 232. It will support a data rate of 19.2 kilobits per second, and this RS-232 is a connector having 25 pins. Next one is RS-449 or EIA or TIA 449. It will support a data rate of 64 kilobits per second, and it is having 37 pins. Next one is V.35, supports up to 2 megabits per second. So it is a 34 pin connector. So this X.25 uses serial communication in either asynchronous or synchronous mode. So what is meant by asynchronous communication or asynchronous transmission, or what is meant by synchronous transmission? So asynchronous transmission means you will be transmitting the data with stop bit and stop bit. You will be sending the data with start bit and start bit. Okay, you will be sending the data with start bit and stop bit. And there is no timing relationship in the asynchronous transmission. But in the synchronous transmission, you will be using only, you will not be using this start bit and stop bit. In synchronous transmission, you will not be using a start bit and stop bit, and you will be continually transmitting the data. So in asynchronous transmission, there will be a gap between the data. There will be a gap between the data in asynchronous mode, and synchronous mode will be having a continuous transmission. Okay. Now next one is data link layer. So in data link layer, the type of protocol what we are using is link access procedure balanced protocol. So it is a version of HDLC, high level data link control protocol. So here HDLC is used in asynchronous balance mode. This data terminating equipment and data circuit terminating equipment are peers and can both perform all the functions. So this LAPB manages communication and packet framing between DTE and DCE. So what is the function of link access procedure balance protocol? It will manage the communication and packet framing between the DTE and DCE. So it will make sure that the frames are delivered in sequence and error free. So it will be using sliding window of 8 or 128 frame. So what it will be using? It will be using sliding window of 8 or 128 frames. LAPB frame types. There are 3 types of frame in link access procedure balance frames. The 3 types of frame is, first one, I frames, that is information frame, and this information frame will carry data as well as next send and next receive counts. Okay, what are the things it is? The information frame will be carrying, information frames will be carrying data as well as next send and next receive counts. Next one is supervisory frame. This supervisory frame will controls the flow of data with receiver ready, receiver not ready, and reject frame. So what are the frames? This supervisory frames, it is having receiver ready, receiver not ready, and reject. These are the three frames that is used in the supervisory frames. So next one is unnumbered frame, that is U frame. This U frame will establish and maintain communication with set asynchronous balanced mode, unnumbered acknowledgement, disconnect mode, and frame reject. So by using these frames, it will establish and maintain communication. Next one is link access procedure balanced frame format. The first one is flag, second one is control, third one is data, fourth one is frames check sequence, that is FCS, and fourth one is flag. So what is flag? It is 8 bits in length and indicates the start and end of a frame. In the first and the last, you are having flag. So it is having how many bits? It is having 8 bits and it indicates the start and end of a frame. Next one is address. Address is 8 bytes. Sorry, not bytes, 8 bits. It is address is 8 bits. And this is used to identify the command and response between DTE and DCE. So what is the use of this address? This address is to identify the command and response between DTE and DCE. Actual address of the DTE is maintained by the higher layers. Okay, actual address of the DTE is maintained by the higher layers, but here this address is used to find the command and response between DTE and DCE. Is used to identify the command and response between DTE and DCE. Now, a value of 0x01 indicates a command from DTE and a response from DCE. So if you're having a value of 0x01 in the address, then the meaning is it is a command from DTE to DTE and response from DCE. The second one is address. The first is flag and the second one is address. In the address, if the value is 0x01, it indicates a command from DTE and response from DCE. Next one is a value of 0x03. It indicates a command from DCE and response from DTE. Okay, if you're having 0x03, then it indicates a command from DCE and response from DTE. Next one is control. Control contain sequence numbers, commands and response for controlling data flow. So what you'll be having in your control? In control, what you're having is sequence numbers, commands and response for controlling the data flow. Next one is data. The size of the data will varies in size and it will contain the upper layer data. So in data field, you will be having the upper layer data. Next one is frame check sequence. So this is 16 bits, and this frame check sequence is used to determine if an error has occurred in transmission. If there is any error occurred in transmission, then it can be found out by frame check sequence. Next one is X.25 network layer. So in X.25 network layer, the type of protocol what you are using is packet layer protocol or PLP. What it is? Packet layer protocol or PLP. So PLP manages the calls between a pair of DTE devices using either a virtual circuit, that is permanent virtual circuit, or switched virtual circuit. So by using permanent virtual circuit or switched virtual circuit, this PLP manages calls between a pair of devices, pair of DTE devices. Okay. So PLP handles segmentation, reassembly, bit padding, and error and flow control. PLP handles segmentation, reassembly, bit padding, and error and flow control. So this PLP is using XPoint one-to-one addressing scheme to set up virtual circuit. So in order to set up the virtual circuit, it will be using XPoint one-to-one addressing scheme. So this PLP operates in 5 modes. The 5 modes is, first is call setup. This call setup is used to set up virtual circuit for switched virtual circuit. Then data transfer. It is used for data transferring. This data transfer mode is used for both the switched virtual circuit as well as permanent virtual circuit. Next one is idle. It is used when switched virtual circuit call has been established, but no data is currently being transferred. So this idle is used for switched virtual circuit. You are establishing the circuit, but you are not sending any data. Then that mode is called idle mode. Next one is call clearing. It is used for end communication between DTEs for switched virtual circuit. So it is used to do end communication. If you want to end communication, then you have to use call clearing. Then next one is restarting, used to synchronize DTE and DCE for all virtual circuit that exist between them. So what is restarting? It is used to synchronize all DTE and DCE for all virtual circuit that exist between them. Next one is PLP frame format. So in PLP frame format, the frame is having 4 fields. One is GFI, one is LCI, PTI, and user data. GFI is general format indicator. It is a 4-bit field and it identifies the packet parameters, whether the packet carries user data or control data, and what type of windowing it is using. Type of windowing, either it is sliding window, okay, and whether the delivery confirmation is required. The receiver, after receiving, whether the acknowledgement has to be given. So these information, this general format indicator will be having. What is general format indicator? It is a 4-bit field and it will give the information about whether the packet is carrying user data or control information, and what type of windowing is used, and whether delivery confirmation is required. So if it is having 4-bit, okay, so if the first bit is 0, then it is user data. If the first bit is 1, it is the data for packet assembling and deassembling. Okay. If bit 2 is 0, then it is local acknowledgement, and if bit 2 is 1, that is remote acknowledgement. Local acknowledgement means acknowledgement coming from the near device, and remote acknowledgement means acknowledgement that is coming from the faraway device. Next, bits 3 and 4. If the value of bits 3 and 4 is 0, 0, then it is reserved. If the value of bit is 0, 1, that indicates a window size of 8. If 1, 0 means it indicates a window size of 128. If 1, 1 means it is an extended format. So what is 0, 0? 0, 0 means reserved. 0, 1 is window size of 8. 1, 0 means window size of 128. And 1, 1 means extended format. Next, logical channel identifier. It is a 12 bits. In the while taking the initial session, I have told that this X.25 can support 4095 virtual circuit. So this logical channel identifier will identify the virtual circuits that exist between the DTE and DCE. This field contains a 4-bit logical channel group number and an 8-bit logical channel number. Okay, so this logical channel identifier will be having a 4-bit logical channel group number and a 8-bit logical channel number. Next one, packet type identifier. So it is 8-bit. Packet type identifier is having 8 bits. So it identifies one of the 17 different types of packets. By using this packet type identifier, we can identify which type of packet it is. Next one is user data. The user data will vary in size, but typically it is 128-bit long. So this data, this user data, it will be having the encapsulated user data for data packets or additional control information. Okay, so this user data will be having either user data or control information. Then addressing. The addressing, what this PLP is using is X.121 addressing. So this X.121 addressing is used during the call setup phase to establish a virtual circuit between DTEs. It is only used for switched virtual circuits. The address consists of 14 digits, 3 digits for country code, 1 digit for network number. This net for a country will be providing only 10 numbers for network. Next 10 digits define the terminal number of the network. So this is a format. First 3 digits for country code, next 1 digit for network number, and next 10 digits for terminal number of the network. Now X.25 is having some disadvantage. First disadvantage is it is having low data rate. What it is having? It is having low data rate. Second disadvantage is it is having flow control in the data link layer as well as network layer. So since you are having flow control in 2 layers, it is an overhead and it will slow down the transmission. It will slow down the transmission. Next disadvantage of X.25 is it is having its own network layer. So since it is having its own network layer, the data has to be encapsulated 2 times. One in its own network layer, another in the network layer of the internet. Okay. So 2 times data is encapsulated in the network layer. So this is an overhead. So these 3 are the disadvantages of X.25. So we have completed the X.25. X.25 is a protocol, 3-layer protocol that connects a DTE and DCE.